Another linear time sorting algorithm is Radix Sort. Radix Sort is best when we're trying to sort a small number of integers, but the range of those integers is rather large. For instance, here's an example, 50 values in the range from 0 to 999. So we would not want to use counting sort, the other linear sorting algorithm in this case, because we would have to allocate too many buckets for the number of values that we have. We've only got 50 values, but we were dealing with 1,000 buckets. And so that's wasted space, and then it's wasted time because we have to process all those individual elements. And so, so the trick then is to use multiple passes of a sorting out approach called bucket sorting. And so we begin then by sorting the value at the least significant position, and then we continue to the most significant. Since we can have multiple values that have the same, say, ones digit, okay, since that's the least significant position, we basically keep a linked list off of the array pointer, and we store the values there. Thus, the first pass will sort the input by adding those numbers to the ones position in that list, and then any subsequent passes. In the case of 2 digits, we would only have two passes. Any subsequent passes take the previous pass's output as its input, and then sorts by that particular digit. So let's take a look at an example. Let's say that we want to use Radix Sort to sort the following list of numbers. So you see we've got, I believe it's 8 numbers, so 26, 73, 89, 64, 2, 7, 42, and 83. This list is obviously not sorted in either ascending order or descending order, and so we're going to sort this in ascending order. So we're going to take each input as it comes in, and we're going to place it in the linked list by the value of its ones digit. So let's take a look at 26. I've highlighted the ones digit here to show that 26 goes in bucket number 6 because we're sorting by the ones position. So where would 73 go? Well, the ones digit in the number 73 is the 3, and so the 73 would go in bucket 3. The 89 would go at the bottom, okay, in bucket number 9. The 64 would go in 4. The 2 would go in bucket 2. The 7 would go in bucket number 7. And finally, the 42, the ones digit there is a 2, so that gets added to the linked list, which already has 2 in it. And finally, the 83 gets added to the linked list that already has 73. Now, to get the output, we're going to read this just like we would a page of text. We're going to go from top to bottom and flow from left to right. So this is the output of pass number 1. It's 2, then 42, then 73, then 83, then 64, then 26, then 7, and then 89. And that output, as I mentioned, becomes the input to the second pass. So the second pass, we're going to sort by the tens digit. And if you notice, the input to the second pass is the same as the output to the first pass. And so we begin with 2. Now 2 is a single digit number, so we have to imagine that there is a 0 in the tens position. So the 2 goes at the top. We then have value 42, and that goes in bucket 4. Value 73 in bucket 7. Value 83 goes in bucket 8. And again, the highlighted digit is the tens position. That's what we're sorting by. Number 64 goes in bucket number 6. 26 goes in bucket 2. The 7 goes in bucket 0. And finally, the 89 goes in bucket 8, which already has 83 in it. Okay? And so the output then of the second pass, we read it the same way, top to bottom and left to right at each line. So it's 2, 7, 26, 42, 64, 73, 83, and 89. So that looks like that, 2, 7, 26, 42, 64, 73, 83, and 89. And if we look at those numbers, we see that they are in fact sorted. And so the benefit of Radix Sort is that it allows us to sort linearly when we have a relatively small number of values that span a wide range of keys. In this case, we had only 8 values, but we had 100 possible keys if we count 0, 0, 0 all the way to 99. There's 100 possible keys, and we're able to use Radix Sort. I will leave this example for you to look at, but it's basically a static example, just like the one I created and just demonstrated. We have our initial list at the top. We make our first pass. We can look at the first couple. We see that we're sorting by the 7, so the 27 goes in the 7 bucket, the 91 goes in the 1 bucket, etc. We see then that the result of the first pass is used on the second pass, and the result of the second pass is in fact a sorted list. And so we will look at when we recap all the sorting algorithms, we will look at the order of this particular algorithm. But in essence, it has to do with the number of positions and the number of digits, the number of values that we have in our list.